Hi all my dear students, we are going to another part of the chapter electricity. In the previous video lesson, we have done MCQs from this chapter. Today, we are going to do the 2 mark and 3 mark questions which come from this chapter. The short answer type questions. Let's go through it, follow it well, pause the video wherever you need, practice yourself, then go ahead. Let's go to the first question. So how you would connect 3 resistors, each of resistance 6 ohm, so that the combination has a resistance of 9 ohm. Also justify your answer. To the 24th question it is. So you have 3 resistors of 6 ohm each. So R1 we have, R2 we have, and R3 we have. How much? 6 ohm each. Now we have to get a resistance of 9 ohm from these 3 together. So how could you connect it? And you have to justify your answer. So justification means either by calculation or by drawing a figure you could make it. Both cases. So here, see, when you connect resistors in series or parallel, we know that in series combination, the total resistance increases. The effective value of the resistance will be greater than the highest value of the individual resistors. That means here we have 6 ohm resistors and we have 3 other, Then if they contain series, you have to multiply 3 into 6, 18 ohm you will get. Here we need only 9 ohm. So the 3 are not contained in series. So mixed combination will be there. And in parallel combination, the basic logic is, if you connect resistors in parallel, then effective resistance decreases. If they are different values, then effective will be lesser than the least value of the given resistors. So here 6 ohms we have 3. Then if they contain in parallel, of course the resultant resistance will be below 6 ohm. So here it is 9 ohm. So it is not completely series and it's not completely parallel. So let's see the trial and error method. So 2 series, 1 parallel you can do. 2 parallel, 1 series you can check. Like that different combination you can check. That's the trial and error method we can say. So let's try. 1 resistance as this way and another as parallel I am connecting. Then to this one a series combination. Then another way of connection. 2 resistors in series and 1 in parallel. So these 2 combination we can try. How it will be? All of them are 6 ohm. This is 6 ohm, this is 6 ohm, and this also 6 ohm. Here also 6 ohm, 6 ohm, and 6 ohm. 2 6 ohms are in parallel here. So here, let R1 is parallel to R2. Then what it gives? The resultant will be, both are of 6 ohm only. So it will be 6 by 2, that is 3 ohm. So this 2 gives you 3 ohm. Then this R3 is series with the is resultant. So R3 in series with this I am calling R dash, suppose the effective of that one. So we get 3 plus 6, that is 9 ohm. Yeah, we got the answer here itself. This way, 2 in parallel and 1 in series if you connect, you will get 9 ohm. See, other option you can try. So this is one way of saying. Now to justify, you can say this calculation. R1 and R2, this is R1 and this is R2 and this is R3. So R1 and R2 in parallel, we get 3 ohm. And that is series with the R3. So you have to add up, so you get 9 ohm. That's fine. Let's try the next one also. Answer is got it? No need, but to show the calculation method. 6 and 6 in series are there. So that's we get 12 ohm total, is it? And this is 6 ohm in parallel. So we have Rp is equal to R1 into R2 divided by R1 plus R2. One of the shortcuts. 1 by Rp is equal to 1 by R1 plus 1 by R2. If you LCM it and reciprocal it, then Rp is equal to R1 into R2 by R1 plus R2. Let's try. It is in series here we get total is 12 ohm. So 12 and 6 in parallel. So 12 into 6 by 12 plus 6. 12 plus 6 is how much? 18. Then 6 and 18 you cancel it. 3 will be there. 12 by 3 is 4 ohm. So effective resistance will be 4 ohm. Here we need 9 only. So this combination is not required. So it's wrong. Here is the correct way. Hope you got it. So this way of question you can get it. It's a logical approach. So basically it is trial and error method we can say. What the required value is there? You check, is it greater than the of the all? Then of course it will be in series combination. If it is in between the resultant we can get, then of course mixed combination, parallel as well as series will be there. Here we go for the next question. In the given circuit, calculate the power consumed in watts in the resistor of 2 ohm. In 2 ohm resistor, what is the power consumed? So 1 ohm is there, 2 ohm is there in continuous series with a 6 volt battery. What is the power consumed in 2 ohm is the question. Here what is the power consumed? So we have question, equation for power, power P is equal to V into I. One equation you can use it, voltage into current. So if you know the current through 2 ohm and voltage across 2 ohm, you can use that equation. Or it is equal to I square into R. Power P is equal to I squared into R. If you know the current through 2 ohm, then resistance only 2 ohm is there. If you multiply I square with R, you will get power. Or it can be V square by R. Voltage across 2 ohm divided by resistance. So any of this equation you can use it to calculate power. So any method you can use it. Different sources are there. Here I am going to do, you can just calculate what is the current through this one. It's very easy because you know it's series combination. So same current passes through this both resistors 1 ohm as well as 2 ohm. So current I you can find out. For that we need total resistance how much? Total resistance Rs will be equal to R1 plus R2, that is 1 plus 2, that is 3 ohm. Total resistance. We have voltage 6 volt. So current I will be V by R. From Ohm's law we know V equal to I into R. So I is equal to V by R, that is 6 by 3, that is 2 ampere is the current. So this 2 ampere passes through both 1 ohm as well as 2 ohm. So current through 2 ohm is 2 ampere. So what is power? Is equal to I square times R. So we get power P is equal to I square into R. If you use it, that is 2 square into 2. That is 2 square is 4. 4 into 2, 8. 8 watts is the answer. The same equation you can get. How you know? V square by R you can use it. So for that voltage across this one you have to find out how 2 ampere is passing through it and 2 ohm is the resistance of, so 2 into 2 I into R, that is 4 volt will be here voltage. Here 4 volt will be there and here 2 volt will be there. Then V square by R, 4 square by 2. What is 4 square? 16 by 2, that is 8 watt again. So any method you use it, you will get the same answers. Power equation you got it, resistance equation you got it, and combination also. See, this is all combined from. Practice it my dears, you get definitely you can score well in the exams. Let's go for the next question. Use Ohm's law to determine the potential difference across the 3 ohm resistor. So here 3 ohm resistor in the circuit shown in the following diagram when key is closed. That means when current passes through this circuit, what is the potential difference across 3 ohm resistance? So voltage across 3 ohm you have to find out. Total 3 resistors are there, 1 ohm, 3 ohm and 2 ohm. You know, very simple circuit. They all 3 are in series circuit. Series combination it is. So net resistance you find, voltage is given. You can find the net current through the circuit. Then current and resistance is we know. Voltage we can find out. So let's use that concept. Here, Rs is equal to R1 plus R2 plus R3. That is 1 ohm plus 3 ohm plus 2 ohm. 1 plus 3 is 4 plus 2, that is 6 ohm is the net resistance. Now, voltage is how much? 2 volt it is. So, it is 2 volt. So, net current passing through, it's a series combination. So, same current pass through each resistors. I is equal to V by R. Ohm's law we are using it. Voltage is 2 and resistance is 6. That is 1 by 3 ampere. 0.33, you can keep it or 1 by 3 ampere it is. That is I. So, here see, positive to negative, this current I passes through each resistors from positive to negative of this circuit. So, how much is current passing? 1 by 3 ampere is passing. 1 by 3 ampere through 3 ohm also. So, voltage across a resistor V equal to I times R. I into R. That is Ohm's law says. So, voltage is equal to I into R. That is I is 1 by 3 into. This is across 3 ohm only we are calculating. Okay. So, across 3 ohm is the resistance. 1 by 3 into 3, that is nothing but 1 volt. So, voltage is 1 volt across 3. So, total is 2 volt is there. So, across 3 ohm, it is 1 volt. Hope you got it. Then here 1 by 3 into 2 is that's 0.6 volt will be here. Then 1 by 3, that is 0.3 volt will be there. Hope you got it. Let's go for the next question. Two wires A and B. Two wires are there, A and B, of same material, having same length and diameters 0.2 millimeter and 0.3 millimeter respectively, are connected one by one in a circuit. One by one they are connected. Which one of these two wires will offer more resistance to the flow of current in the circuit? Justify your answer. So, which will offer more resistance? So, which one will have more resistance is the question. So, it's regarding the question of resistance. In the question is given, they have same material. If two wires are same material, then definitely their resistivity will be same. Resistivity will be same. So, we can say resistivity of the first wire, rho 1, will be equal to rho 2 because resistivity depends only on the material and temperature. So, here given materials are same. So, rho 1 equal to rho 2. Having same length, so length also same, L1 is equal to L2. Length is same. But they have diameters different. One is 0.2 millimeter and second one is 0.3 millimeter. So, diameter D1 is 0.2 millimeter and D2 is 0.3 millimeter. Now, which one will offer more resistance when the current passing through it? Justify your answer. That's the question. So, we have resistance equation. R is equal to rho into L by A. Resistance is directly proportional to length and inversely proportional to cross-sectional area. So, R is equal to rho into L by A. The equation. Here, rho is same, L is same. So, we can say R is inversely proportional to area of cross-section, A. Now, diameter is greater for D2 and lesser for D1. So, which area is greater? A2 is greater than A1. Diameter from diameter, of course, you can find radius also. We have area of cross-section. A is equal to pi R square, or this will be pi into D by 2 is the area, you know. So, pi D square by 4 also you can use the equation directly. So, here that is area. So, here which area is greater? A2 is greater and A1 is smaller. If area of cross-section increases, resistance will decrease. If area of cross-section decreases, resistance will increase. So, we can say R1 is proportional to 1 by A1 and R2 is proportional to 1 by A2. Then we know that A1 is less than A2. Area of cross-section of first wire is less than because it's of less diameter. So, if A1 is less 1, then R1 is greater than. Therefore, R1 is greater than R2. So which one will give more resistance? The first wire will give more resistance, or the wire with a diameter of 0.2 millimeter will give. So two wires of same material, same length, then the thin wire will give more resistance. Thin wire means the thickness, diameter is less. Thick wire will have less resistance. So question is here, one by one they are connected. Then which of these two wires will offer more resistance to the flow of current? So which one? The first wire will give more resistance because it is thin or its radius of cross section is lesser. Hope you understood it. Pause the video, read the question again, then practice it. Let's go to the next question. States Joule's law of heating. How is this effect useful in electric circuits where fuse is used as a safety device? Statement of Joule's law. We know the heat produced in a conductor due to passage of the current is directly proportional to square of the intensity of current, resistance of the material, and the time of flow. So three concepts we have. H is proportional to I square, H is proportional to R, and H is proportional to T. From these three together, we can write H is equal to I square R into T. H equal to I square RT. This equation is the expression for Joule's law. So statement you can give and expression you can give. Hope you got it. Refer the textbook also and make sure you know the statement. Now concept is, how is this effect useful in electric circuits where fuse is used as a safety device? You know electric fuse that is used as a safety device when overloading or extra current passes through a circuit. Then the fuse melts and it protects the device from overheating or the melting. So that fuse wire or fuse material used should melt at when extra current passes through the rating. So for the melting, heat should be produced. So because of this fact, we know H is proportional to R. H proportional to R. And H is proportional to I square also. So whenever more current passes, more heat is produced. To the square times heat is produced. If just current doubled, then 4 times the heat produced will be done. Then this fuse wire is made up of high resistance and low melting point is another factor. Low melting point is the two qualities of a fuse wire. Thin wire will be used of the material because thin wire means radius of cross section is lesser, hence area of cross section is least, resistance will be greater. So more heat will be produced. Then low melting point it should easily melt at a high temperature. That way fuse is working. So heating effect of electricity is directly implemented in fuse wire. This is a safety mechanism. Hope you got it. Let's go for the next question. Calculate the resistance of a copper wire of length 1000 meters and area of cross section 2 millimeters square. Resistivity of copper is given 1.6 into 10 raised to minus 8 ohm meters. You have to find the resistance. We have the equation R is equal to rho into L by A, length by area of cross section. We have length is given 1000 meters. That you can write as 10 raised to 3 meters or 1000 meters. Then we have area of cross section is given 2 millimeters square. So area A is equal to 2 millimeters square. Millimeter you should convert to meters. 1 millimeter is equal to 10 raised to minus 3 meters. So it is 2 millimeters square it is. So 10 raised to minus 3 square should be. So it will be 2 into 10 raised to minus 6 meters square. area of cross section. 2 millimeter square is given, that is converted to meter square by multiplying with 10 to minus 6. How it is? 1 millimeter is 10 to minus 3 meters, so square it. Area of cross section is given. Then resistivity is given rho. That is 1.6 into 10 to the power minus 8 ohm meters. So as an SI system, no need to convert. These three data is given. Just substitute, you will get the answer. Let's check. R is equal to 1.6 into 10 power of minus 8 into L is given 10 raised to 3. I am writing for the easiness of calculation. Divided by area of cross section is 2 into 10 raised to minus 6 meter square. See, while attending the numerical question, first of all, report the data. As it is given, wherever conversions required, you should do it. For that, you will get step-by-step mark. Then write the proper equation. If the same equation you have to use, then use that way, or you have to alter the equation, which term to find out. Then substitute properly, you will get the next marks. Then last calculation marks are there. So here, it is 1.6 times 10 raised to minus 8 into 10 raised to 3. 10 raised to minus 8 into 10 raised to 3 is 10 raised to minus 5. Then divided by 10 raised to minus 6 is there, you take to numerator, it will become 10 raised to 6. 1.6 by 2 is there, 1.6 by 2 is 0.8. So it is 0.8 into 10 raised to minus 5 into 10 raised to 6. 10 raised to minus 5 into 10 raised to 6 is 10 power 1, that is 10. 10 into 0.8, it is 8 ohm. So answer is 8 ohm. So this wire will have 8 ohm resistor. Hope you got it. Let's go for the next question. An electric source can supply a charge of 500 coulomb. So there is charge of 500 coulomb. If the current drawn by a device is 25 milliampere, find the time in which the electric source will be discharged completely. So discharge completely means is pass the current completely out. We have the equation for current, charge and time relation. I equals intensity of current I is equal to quantity of charge divided by time taken. I is equal to Q by T. Here in this question, we have Q is given 500 coulomb as a SI system as it is given. Then intensity of current I is given 25 milliampere, that is 25 into 10 power of minus 3 ampere. Wherever milli comes, 1 milli is equal to 10 raised to minus 3, 1 by 1000. Centi comes 10 raised to minus 2. Micro comes 10 raised to minus 6. So here milli comes, so 25 to 10 raised to minus 3 ampere. Q and I is given, you have to find what? The time you have to find out. So this equation you have to rearrange. This as T is equal to Q divided by I. Those who feel difficulty to transfer it, you could remember the triangle. This I is equal to Q by T. So T is equal to what? Q by I. So T is equal to Q by I. How much is Q? Q is 500. Divided by, how much is I? 25 into 10 raised to minus 3. So if you rearrange it, it will become 50 by 25, you know, that is 2. So this is 20 into 10 raised to 3. 10 raised to minus 3, you take the numerator, that is 10 raised to 3. In 50, 25 is 2 times, so 20 into 10 raised to 3 seconds will be the answer. So in this much second, the source will completely discharge, means the total charge will be flow out. Hope you got it. Let's go for the next question. The filament of an electric lamp draws a current of 0.5 ampere, which lights for 2 hours. 2 hours it lights for. Calculate the charge that flows through the circuit. See, the same question, but different concept is there. So you have to find the charges. Q, how to find out? We have the equation I is equal to Q by T. So from this, if you rearrange Q is equal to I into T, this charge would find out. Current into time should be. Now here, time and current is given. Current I, intensity of current I is equal to 0.5 ampere. And the time of working T is equal to how much? 2 hours it is, 2 hours. So hour should be converted to seconds. 1 hour is 60 minutes and 1 minute is 60 seconds. So this is 2 into 60 into 60 seconds. That is 2 into 6 into 6 is 3600 seconds. That is 7200 seconds. That is T. You convert it to seconds. Hour to seconds. Then what is Q? I into T, the charge. So it will be I is 0.5 into T is 7200, this one. So this will become as 0.5 into 72 is 36. So 3600 into that much of coulombs will be Q. 3600 coulomb is a charge. Total charge it flows through it. Because time is 7200 seconds and I is 0.5 ampere. 0.5 means 1 by 2, you know. So 7200 by 2 is 3600 seconds. Hope you got the answer. Let's go for the next question. Two parts are there here. A, state Ohm's law. You have to state Ohm's law. What Ohm's law says? The potential difference across the ends of a conductor is directly proportional to the intensity of current passing through it, provided that physical constant like temperature remains constant. The statement you should do. Write the formula for equivalent resistance Rp of the parallel combination of three resistors of values R1, R2 and R3. So you have to write the formula only, not to derive there. So all of you know the equation. So for Ohm's law, after statement, you have to denote it symbolically also. V proportional to I and V is equal to I into R. This is the Ohm's law. Now, here the given, write the formula for the equivalent resistance. So, Rp, you have to make it, that formula is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is the parallel combination. So you have to write this equation. Sometimes the question will be to derive this expression. Then derivation, proper derivation should be given. Okay, hope you got it. See the second part B. Find the resistance of the following network of resistors. What is the resistance of this following network? That is the B part. So here R. Three resistors are there. All are R ohms. So you can keep it. This is R1, this is R2 and this is R3. Then step by step you have to follow. Here see R2 and R3 are in parallel. Is it? Then that is in series with R. First you have to identify which all are series, which all are parallel. So here R2 is parallel to R3. So their effective R dash is equal to R2 into R3 by R2 plus R3. That will be equal to R2 and R3 all how much? R only. So that will be R by 2. So R dash is R by 2 of these two. Now R1 is there. R1 and these two are in series. So we have R dash is series with a R dash. So net resistance Rs is equal to R dash plus R3. R1 is given. So this will be R plus R by 2. R plus R by 2 is this LCM, take it 2R plus R, that is 3R by 2 is the final answer. Have you got it? So 2 are parallel, 1 is series. So first parallel effective one, then add with the series one, you will get the total resistance of the circuit. That is 3 times R by 2. Next question, let's check. Draw a schematic diagram of a circuit consisting of a battery of 4 dry cells of 1.5 volt each, a 2 ohm resistor, a 6 ohm resistor, 16 ohm resistor, and a plug key, all connected in series. All are in series. Put an ammeter to measure the current in the circuit and a voltmeter across the 16 ohm resistor to measure the potential difference. Use Ohm's law to determine ammeter reading and voltmeter reading when the key is closed. So you have to draw the circuit diagram first of all, then you have to calculate the current, that's ammeter reading, then voltage across 16 ohm you have to find out. So normal question only, but while reading is better, so definite marks. You should get the marks. So let's draw the figure first of all. So here 3 resistors are in series. 1, 2, 3. Then there should be a plug key and 1 ammeter. Then a battery of 4 dry cells of 1.5 volt each. So 4 dry cells means first one, second one, third one, fourth one. So 4 dry cells you have to add like this total. So total will be how much? Each one is 1.5 volt. So 4 into 1.5. How much it is? 6 volt battery is there. How is getting 4 into 1.5? That is 6 volt. Then what is there? An ammeter is connected. Give the values for this one. It is 2 ohm. This is 6 ohm. And this is 16 ohm. Now one more is given. A voltmeter across the 16 ohm resistor. So a voltmeter is connected across 16. So across 16 only the voltmeter is connected. You have to find what? Ammeter reading and voltmeter reading. Ammeter reading means I you have to find out. Total current how much is there? Because ammeter anywhere you can connect, but it should be in series. And in series circuit, same current pass through each devices. So let's find I first of all, ammeter reading. Here 2 ohm, 6 ohm and 16 ohm are in series. So here we have total resistance R is equal to R1 plus R2 plus R3. That is 2 plus 6 plus 16. That's equal to 16 plus 6, that is 22 plus 2, 24 ohm. That is R. Now voltage is given. How much? 6 volt. 1.5 times 4 is that is 6 volt. Now we have to find I. I is equal to the net current passing through it. That's the current passing. I is equal to V by R it is. That is 6 by 24. How much it is? 6 by 24 is 6 and 24. 4 into 6. That is 24. So if you cancel this, 1 by 4, that is 0.25 ampere. So 1 by 4 ampere is there. The net current passing through. So that current will pass throughout the circuit. When key is closed, it's passed throughout the circuit. This ammeter. So ammeter reading is how much? 1 by 4 ampere is ammeter reading. So I is equal to 1 by 4 ampere. Now the voltmeter reading, that is voltage across the 16 ohm. Voltage across the 16 ohm. So voltage V equal to V16 is equal to I into R. Ohm's law. Current into resistance. How much is current? Everyone is same. 1 by 4 into R is how much? 16. That is 4 volt. So across 16 ohm, there will be 4 voltage of potential difference too. So voltmeter reading is 4 volt. That is across 16 ohm only. So Ohm's law we used for this purpose. Here, first we draw the circuit. Ammeter is there, voltmeter along 16 ohm. Then you solve it. Let's go for the next question. A 2000 watts heater has a resistance of about 25, whereas a 100 watt bulb has a resistance of 500 about. When 220 volt is applied on these, then which of the two can carry large current, may be used with a electrical circuit having 1 ampere rating, will be fitted with a 15 ampere electric board and not with a 5 ampere electric board? Justify your answer in each case. So 3 sub questions are there. A bulb is there and a heater is there. Heater is of 200 watts. Bulb is of just 100 watts only. So basic connection type question as well as the numerical values you have to find out it. Okay, so both are connected to single circuit, 220 volts. So can carry which will carry large currents. So current through this one you can find out. So for that purpose, either you can calculate the resistance of each one. If resistance is greater, less current will be there because same voltage they are connected 220 volt. Then or directly you can find the value of current because power is given and voltage is given. So any one concept we can make use of. Here, option A, current through heater. So we have power is given 2000 watts and voltage is given 220 volt. Then from there directly current you can find it. What is it? IH is equal to power by voltage because we have power P is equal to V into I. So I is equal to P by V. I is equal to P by V. So since V is constant, we have I is proportional to P. If V is constant, I is proportional to V. Which is more power? Heater have more power. Bulb have less power. So which have greater power? It carries more current. Bulb have less power, so it carries less current. So current through heater is greater than current through bulb. That's the concept we are getting. Because here power is proportional to I at constant voltage. As you got it, if voltage is kept constant, then power is proportional to I. If power increases, current increases. Second one, may be used with an electrical circuit having 1 ampere rating. So 1 ampere rating, where it can be used with. Then of course, that circuit also should have that much current only. So let's try. So here, for heater, power is almost 2000 divided by 220 volt. Is it? It's almost greater than 1 ampere. Now for bulb, if you do it, the second part, B. IB if you calculate, that is power by voltage. Power is how much? Just 100 only divided by 220 it is. So 10 by 22 is coming. That is 5 by 11. That is equal to 0 point. How much are the 4 is the 4 and 5 you can see. That much ampere only is passing through. So it can be connected with a 1 ampere rating. That's fine. Got it. So bulb can be connected with 1 ampere rating. So you have to do these calculations. Then that's a justification. Now the part C will be fitted with a 15 ampere electric board and not with a 5 ampere electric board. You know, in our at domestic circuit, we have 5 ampere, 10 ampere or 15 ampere circuits are there. So the devices which have greater powers have to be fit with a high ampere cases. So it is content should be with 15 ampere is heater. So it is heater. A normal one we use the 5 ampere ratings. Hope you got it. This is a part of domestic circuit as well as the calculation from the Ohm's law and power equations. Let's go for the next question. Define electric power. Express it in terms of potential difference and resistance R. V and R, you have to express it. What is electric power? Electric power is defined as the rate of consumption of electrical energy by a device. So how much it consumes electrical energy per unit time. That's called electric power. So electric power is the amount of electrical energy consumed per unit time. Just 1 second, how much it is? Because power P is equal to energy by time, you can give it. Now express it in terms of potential difference and resistance. So resistance and potential difference, you have to make it. For that purpose, we have basic equation. We have this power P is equal to energy by time. So energy for what? To move charges from one edge to other parts. So if you move that one, then energy is going to work done only. That's work done by time is the power P. That's equal to voltage into charge by T. V into Q by T. Now what is Q by T? That is current, I only. So that is V into I. Now from Ohm's law we have I is equal to V by R. So that is V into V by R. That is V square by R. So there we made use of I is equal to V by R we used, and also I is equal to Q by T. These two concepts we used. Hence we got P is equal to V square by R. That's a required equation for here. P is equal to V square by R. That we proved. Now the second part. An electric oven is designed to work on the mains voltage of 220 volts. So voltage is given 220 volt. This oven consumes 11 units of electrical energy in 5 hours. Calculate the power rating of the oven. A part. B. Current drawn by the oven. C. Resistance of the oven when it is red hot. So here power rating is given how much energy it consumed. We have energy E is equal to power into time. Power into time. Now power rating you have to find out. So power P is equal to energy by time, we can say. Here energy is given how much? 11 units of electrical energy is given and 5 hours. So 11 units means that is 11 kilowatt hour. So energy is 11 kilowatt hour, kWh, divided by time is given how much? 5 hours is given, that is 5 hours. So 11 kilowatt hour by 5 hour. So hour no need to calculate, convert, can cancel. 11 by 5, that is 2.2 kilowatts is the power rating. So 2.2 kilowatts we are getting. 11 by 5 is it. Now, so here got 2.2 kilowatts. Current drawn by the oven. Current you have to find out how much it is. So we have current I is equal to power by voltage is there. So, or here is given power is equal to this much we got. Energy also given there. So any of this equation you can use it. Current I is equal to power by voltage. So power is how much? 2.2 kilowatts it is. So that is 2.2 into 10 power 3 watts divided by voltage how much is converted to 220 volts it is. So this will be equal to 2.2 into 10 raised to 3 is 220 into 10 raised to 1. Is it? So you have to 3 zeros you have to put it with multiply. Is it? So 3 decimals we do, then it will be 220 it is. That is equal to 1 ampere. 2.2 into 10 raised to 3 it is. So that will become 222 and then 2 zeros are. So that is 220 by 220. That's 1 ampere. Now, resistance of the oven when it is red hot. So maximum resistance how much will be? So for resistance we have, it's red hot. So R is equal to total energy how much it's consumed. That is energy divided by I square into T equation you can use it. How much is that? Total energy how much is consumed? We have 11 kilowatt hour. So that is 11,000 watt hour. You could multiply that one. Divided by I square. I is given how much? 1 ampere. T how much? 5 hours. So 1 ampere is passing through it. Then 5 hours it's doing. So that will be equal to 11 kilowatts hour it is into 3.6 into 10 raised to 6 joules are there. Divided by time is how much? 5 hours. So 5 into 3600. 5 into 3600. So joules you convert, then time to seconds you convert. Then resistance you will get. SI unit of time is seconds, you know. So if you do it, this will be 3.6 into 10 raised to 3. So 3.6 cancels. 10 raised to 3, 10 raised to 6 cancels. 10 raised to 3 is coming. Then it will be 11 by 5, that is 2.2 into 10 raised to 3. That is how much? 2.2 kilo ohm is the resistance of the wire. So how much energy it consumes? It's equal to I square RT, you know. The total heat is produced. Hope you got it? My dear students, we'll continue this discussion in one more lesson. Stay tuned. Thank you for watching.